World stage. Nowadays, the world population is around 7 billion people, and the forecast for the 2050 shows an important increment up to the 9 billion people. According to a recent study promoted by the Chinese government, in the 1980s, scarcely the 18% of the population lived in urban centers and cities. But more recently, in the 2012, up to the 60% inhabited in a city or metropolis, and the prediction is to achieve the 80% in the 2050. It is important to notice that human feed habits, waste morphology and volume produced by a human being living in a city, besides one living in the countrysides, are very different. In the city, each inhabitant produces a minimum of 1.5 kilograms of waste on a daily basis. Yet, adding to this all the waste generated by the industries and human activities developed to provide food, clothes, medicines, cars, and energy. What can we do with waste? Main politics about waste management are based on treatments that may vary from compost for the organic matter to incineration. Any of these solutions is not energy efficient and economically unsustainable without grants and administrative funds. High tipping fees force administration to assume financial risks. But how can we get cash from trash? InfinitVE proposes a balanced solution. A new design for an industrial plant where state-of-the-art technologies of waste treatment and valorization minimize the final waste delivered to dumping sites, obtaining final products of high energy value, like boosted coal pellet and biodiesel. Through these products, we can generate energy that will be used in the same cities that are feeding back our plants with new waste to be treated. Investment motivation. InfinitVE, an engineering company specialized in development of high-value environmental solutions, offers you the chance of sharing a new way to environmental and energy excellence, using the most advanced technologies focused to energy recovery from urban and industrial waste. InfinitVE is working in the development and implementation of several waste treatment and valorization plants in Europe, in countries as Holland, Spain, Bulgaria, Romania, Poland, and Germany, as well as projects in Chile, Costa Rica, and Nicaragua. These projects are now in different administrative stages to get permits for the construction and management of the plants. Plants based in our technology and design and knowledge. Process. The process starts with the reception of waste to be treated in the plant. This waste comes from industries and standard waste treatment plants for the municipal solid waste. The input fractions can be glass, organic matter, metal, ceramic and other inerts, wood, and other cellulose composts, polymers, textiles, oils, and non-dangerous solvents. The plant is designed to receive any organic waste from any industrial activity, agricultural and livestock processes. The recovery process is divided in 3 different phases. The first phase is based on the pretreatment of the mixed and non-classified waste, allowing us to extract the recyclable fraction following the European and American environmental guidelines and regulation. The remaining fraction is transformed to obtain the valuable subproducts with high energy content. The pretreatment process starts with the accumulation of the litter in storage tanks that will provide a constant supply without holes. Previous separation of the large objects is needed to avoid dangerous situations. Once inside the truck, the mixed waste falls in the scratch, obtaining pieces not bigger than just several centimeters, always below 20. After the ripping process, the small pieces go through the cleaning phase. Pumping water steam at high pressure cleans the surface of the rubbish and kills any bacteria in the organic matter, dropping down to zero flavors emissions. It is important to focus on the fact that it is a closed-loop process, meaning that we reuse water and therefore minimize the consumption of water in the plant. Once dried, we reach the classification process of the different recyclable parts by separating metals, glass, and thermoplastics. The mechanical classification processes basically consist on eddy currents for the polymers, electromagnet for the ferrous metals, and decantation for the glass and non-ferrous metals. These recyclable fractions are sold to recycling companies that will reintroduce them into the industrial production processes. The remaining mix, essentially composed by organic matter, textile and non-recyclable polymers, goes then through to the second phase, consisting of a set of transformation processes to convert it into energy-valuable subproduct. The remaining mix of treated non-recyclable waste is introduced into a ripping mill to reduce the particle size up to a maximum of 2 cm, identified as particles or waste pearls. These pearls are stored in big tanks that enables a constant entry of ore into the reactor. The process starts here a parallel circuit to get maximum efficiency output rate. 3 reactors, up to a maximum set of 10 reactors, are arranged according to the final product focus. The mix processed by every reactor is adjusted to the production goals. The reactor is mainly pyrolysis and gasification reactor designed to obtain synth gas and roasting for the coal-enriched pellet. Depending on the process, mix and set of temperatures, a catalyzer may be required to initiate the chemical reactions. Once the catalyzer is mixed with the waste pearls, due to the high temperatures and the absence of oxygen, which are pyrolysis principles, the transformation reactions ignite. From these reactions, we get the energetic subproducts, gas and solid. The solid fraction is recovered and treated to its final delivery packing, pellet. The gas fraction is then conducted to a distillation condensation tower, where using a low-temperature system we obtain the liquid subproduct, liquid hydrocarbon. The off-gas fraction, mainly composed by methane and butane, is then used as feeding product for a combustion engine. The engine provides the electricity and the main percentage of thermal energy needed by the plant. Therefore, we can nearly achieve an energy self-sufficient plant. The resulting gases pass through several filters pouring to the atmosphere CO2 and closing the carbon cycle.